when you're troubleshooting the control circuit of any of our Kval machines, they're all basically the same circuit. We start up here at the very top at the control circuit. That's where the control transformer is. And it comes, this is the primary side, and we go through the transformer, and then we come out, and this is the fuse on the secondary side of the control transformer. At that point, we go to our control switch, and then when we turn that switch on, we turn on a light bulb. So from there, that turns on 1A. And then from there, we go down, and we're turning on power supplies and stuff over here. But we come down here to our overloads. So from 1A to 1B, that's going to be our high frequency disconnect, telling us that that's turned on. And then we go to the overload for the lock bore, the bolt drill, the 6-shooter, the ball catch on the in feed, the ball catch on the out feed, and the 8-shooter. And once we get all of these overloads activated, we get number 3 over here. And then we start our E-stop circuit, where we start with 3, and we go to the gate latch that's on the back side of the machine, and then there's a push button on the console, and then there's an E-stop on the between hinge 1 and 2 on the 990 example that we have here. Once we get that, we got our 3C. Then we have our stop button. If that circuit is closed, we go to 4. And then what we do is we hit the start button down here. That turns around and latches the ACR circuit, which turns on the ACR, which holds it. Now, anytime that any one of these buttons or E-stops or overloads are tripped, it's going to turn off this ACR circuit, and then you're going to have to go and do your troubleshooting. First, if there's no lights on at all, and your switch is turned on, your control transformer switch is turned on, we got to go take a look at the control transformer. So let's go take a look at your control transformer so you're familiar with that. Okay, before you start checking your control circuit, you want to lock out, tag out the machine to check ohms on your overloads and your E-stops all the way up to your start circuit. What I advise doing is turning your disconnect to the off position, in this case, opening up this tag out here, put your lock in there, put your tag on it, and then you lock it, turn your key, and pull your key out. Make sure it's locked so now it won't open up. Now the other thing that I'd recommend is if you have a power coming in from out on your wall somewhere, is go ahead and turn that disconnect off or circuit breaker off and lock out, tag out that one as well. If we don't have any lights, we want to know if we have power to the top side of the control transformer or the primary side. This is going to be, you're going to be checking AC voltage. This is going to be either 208, 230, or 460 based on your specs at your plant. So if we take and check between H1 and H3 in this case here, you should have 230 volts. We have about 240 here. So that means that is good. We got power coming into our transformer. On the output side of our transformer, we have, over here on the far left is our neutral. Over here on the far right is where the power that comes out of the transformer into the fuse. So we check there and we should have about 120 volts AC. Then we check over to the left side of the fuse, and that is the output side of the transformer on the fuse side. So if you have power there, 120 volts there, that fuse is good. If we do not have power there, we have to replace this fuse. Once the power goes through this fuse, it goes to 1A, which is there's a wire behind this fuse that goes out to the gray terminal blocks where our control transformer circuit begins. So in this case, we have 120 volts, so this transformer is good. Now, if we do not have power to the primary side, we have to look for our primary fuses. Generally, we have 2 fuses for single phase. So what you'd want to do over here is you'd want to check from the top of the first fuse on both of them, between leg 1 and 2. You should have, in this case, 240 volts. Then what you want to do is drop down to the bottom of the second one, and from the top of the first one to the bottom of the second one, you should still have 240 volts. If you don't, that fuse on number 2 is bad. And then once we verify that, you go to the top of the second one to the bottom of the first one. If you do not have 240 volts, that means fuse number 1 is bad. As you can see right now, we only have control power. So at this point, we need to go verify our control transformer to see where our problem is. Okay, now that we located the overloads in our high freq panel, make sure our power is off again, locked out, tag out. We're going to check the ohms between each overload to make sure that they're closed. So if you go down here at the bottom, you go between the first screw on the left and then the second screw, you want to check each one to make sure they ohm out. If one of them doesn't ohm out, that means we have a bad, we don't have a bad, we have a tripped overload. So for example, on this one here, this one didn't ohm out. So what I want to do is push in that reset button. Now I got that one to ohm out. So you want to just basically go down and do every single one of them to make sure that they're all okay. Here's an example of an older style overload that we used to use years ago. You have a manual trip button here. It's a little black button, it's round. Whatever you do, do not hit that one. If you're going to reset an overload, press this green button here. On some of the older ones, they were red buttons. So, but if you want to check and see if an overload is good, you can ohm them out by going from the bottom terminal here on the left side to the top terminal here. If it ohms out, you are good. If it doesn't, your overload is bad, and if you press the reset button and it still does not ohm out, you're going to have to replace this overload. So now that we have the control power, the overload on, the next step is our e-stop is not working. So again, we need to go look at our gate switch and our buttons to make sure our e-stop buttons or our gate switch is not open. The e-stop circuit goes from 3 through 3C to 4. So what we want to do is we want to check for ohms between 3 and 3A. If you get 0, that means that circuit's been completed, so we move to 3B. And if that circuit's completed, we go to 3C. If that circuit's completed, we go to 4. And if all four, between 3 and 4 is met, that means our e-stop circuit is good. If one of these is missing between 3 to 3B, what we do is we go to our electrical control circuit page and look and see what 3B has for a contactor on it, and then we go check the e-stop that makes that happen. Now a lot of times it's either going to be a gate switch or an e-stop on the control circuit panel, or an e-stop on the front section of this 990. The next step is the stop circuit. If you don't have the stop light on, you need to go and check ohms again between 3 and 4. If you have ohms between 3 and 4, that means that stop is working. If you don't have ohms between 3C and 4, we need to go and check that stop button or the contactor on the back side of the stop button on your console. Something in there is either loose or the contact is loose from the switch itself. In checking for 5, that's part of the start circuit. So as soon as you hit the start button on your machine where the start stop switch is, you should have number 5 come on. And when the number 5 comes on, the start light should come on, and over here to the left is your ACR circuit. And if you check between number 2 and number 5 over here, you should have 120 volts. Also, that light there at the bottom should light up green when that happens. Okay, now that we got our stop button on, the next thing we need to do is hit our start button. Now if the start button goes on when you hit the start button and it goes off as soon as you let go of the start button, that means our relay, our ACR relay is bad, or we need to see why it's not latching. What you want to do first is you want to check up here at the very top between L and N for 120 volts AC. If you have 120 volts AC and this green light is out, that's your 24 volts saying it's on. You want to check for 24 volts on the bottom side here. Most likely it's going to be 0. What you want to do at that point in time is remove the DC plus wire. Once you remove the DC plus wire, check for voltage again and make sure you have 24 volts. If you have 24 volts now, what that tells you is your 24 volt DC plus is shorting out somewhere on your machine. 9 times out of 10, when it's shorted out, it means that you probably have an eye that's been damaged, and the eye's shorted out, and then at that point in time, it will take your 24 volt DC to ground, which will turn it out. Once you have it, your 24 volt fixed, as you can see now, you have the green light saying it's good, and if you check for 24 volt power here, you should have 24 volts.